Hi, this is your host Swapnil Bhartiya, and welcome to another episode of TFiR. Let's talk. And today we have with us Sal Kimmich, Developer Relations at Sonatype. Sal, it's great to have you on the show.
Great to be here. Thank you.
Yeah, it's my pleasure to have you on the show. And this time we're going to talk about how SREs are kind of changing developer culture, what impact it has on the developer culture. But before we get deeper into this topic, I would ask you, since you work closely with developers, how would you define SREs? What is their role? How is it like when we look at day-to-day job of a developer, right? How what has changed in reality versus a label?
Yeah, so SRE or site reliability engineering, I've heard it defined lots of different ways. One great definition is it's what happens when developers start to do what used to be operations. But that really brings together the idea that SREs are helping to sort of work on automation and bring together systems that make everything more reliable. That's in the definition of the name. And when we're speaking to reliability, we're speaking to technical reliability. So guaranteeing that we've got a certain level of uptime. But on the other side of that, this entirely sort of developing new field has meant that we've had to realize that reliability does not mean 100%. So we're starting to understand how we engineer for expected failures as well. And that really is changing the way that we've decided to develop as teams.
We do talk a lot about all these cultural shifts are happening. Tax are changing, DevOps, DevSecOps, NetOps. You folks work really closely because you actually solve a lot of problem for customers and users. How much of this is happening in real versus what we talk a lot about? So how much you have seen that the cultural shift is happening within companies? Have you folks done any survey, or you have any stats where you say, you know what, yeah, the last survey showed that 60% folks are still struggling with embracing SREs. So talk about the reality there.
Yeah, so I mean, the cultural shift right now is happening in part because it's sort of a new field, new idea, right? So this came about 10 years ago from Google originally, the sort of SRE unit. And about 70% of actively employed SREs say that they've been employed in that role at their company for 3 years or less, right? So these are really real new approaches to the way that we want to do development. I will say as well that about a third of developers report that they believe that the SRE is and should be within their DevOps team. So that's something that's interesting and really depends on sort of the size and maturity of your technical team. But one thing that I think we really have to note to understand the culture shift comes from a technology shift. We have radically improved our ability to do telemetry in the last 5 years. So the ability to measure almost every aspect of what our architectures are producing. And so that has brought us to two different approaches, really. And this is sort of where we get that cultural shift or that cultural clash. Oftentimes, people have things hooked up to Datadog, for example, right? And you will be doing something which gives you a lot of metrics, a great understanding of the numbers behind your system. But I would still call that just dashboard DevOps. The real difference, if you're doing this well, is making sure that you have a meaningful narrative behind why you are holding the metrics that you're holding, and to remove the ones that have no high value, right? Especially if there's overhead to computing them. So a really great example of this actually comes from cybersecurity. It's one that I've been considering often, especially for cloud systems. We often have to intake open source packages, and that is one of the largest vectors for cybersecurity attacks, right? It also means that even if they're not attacks, you're often inheriting technical debt from unsolved problems in these packages when you bring them in. If 90% of our source code that we are now playing with comes from open source, that effectively means 9 out of 10 of your developers are not on your payroll, and you're inheriting all of their ideas and debt. So it's interesting. In this case, here's an example where you can choose two key metrics, which are going to give you an end-to-end idea of what the reliability is of that system intake and output. So you can, and typically always will be, measuring your MTTR. So this is your mean time to response. This is how long it takes you from a serious incident, a major outage, for example, to your time of resolution, right? That is essential. Every SRE team tracks this, and every DevOps team or any company with a PagerDuty will be tracking this. It also is highly correlated to something called mean time to update for the packages that you intake, meaning if you look at how often an open source package takes in new dependencies and updates their own dependencies, that has a direct correlation to basically the cybersecurity level of your own company's source code. So that's a really good end-to-end example of using key metrics that make sense and are easy to understand as a human being that correlate strongly between each other.
We live in a world which is run by open source technologies. That is not going to go away. Bugs are part of software development process. That is also not going to go away. Only thing that can go away is misconfiguration, because human errors that you can eliminate. So realizing this fact that we live in this world, talk about what kind of how companies should embrace the SRE culture, so that, because security is something that cannot be compromised.
Exactly. Well, I'll give you two very different answers to that question because they both really need to be done in tandem to solve the problem. The first one is at a broader level. Even if you are consuming open source as an enterprise, if you make a patch or you recognize or you develop a feature that's valuable, contribute it back, right? Especially when it comes to something which is a potential security risk or patch. That's absolutely essential. You should know how and when and why to report those. So on that level, it really just takes the understanding and responsibility that if companies do not participate with that due sense of responsibility, the packages that they rely on will not be able to be maintained by volunteers. Secondarily, internal to a company, it's really important to understand that we have moved from the place through the development of the new telemetry and monitoring that we have from being able to do the more traditional approach of waiting for an incident in order to develop an incident report, right? So a nice way that I put this is, what are other spaces where we can have low to no failure rates, and how do they deal with potential major concerns? Great example of this is flying airplanes. So after a major airplane crash, you will have the black box, which is in the back of the airplane, dug out of the wreckage, and it has a bunch of monitoring data of what was the state of the system before it went down, right? So that is very similar to the way that we in modern day development try to do our incident reports. We wait until there's a major outage, we call the people on PagerDuty, we get it patched up if we can, and then we do a post-mortem on that. Culturally, I think it's much more important to consider making pre-incident reports. Now, pre-incident reports can have the exact same format as your post-incident report, right? When you're making that initial report, you do not know exactly what the root cause was necessarily. You may not know what the true root cause or extended outcome would be of a potential incident. But when developers are trying to make feature improvements with acceleration in mind, they often, you'll see these in the stand-ups, you'll see these in the release notes sometimes if you're lucky, but they will release things with some concerns, right, about how it will be operating in the larger contextual system. And these are typically, right, you're most likely to get an outage after a major release. It makes absolute sense. So pre-incident reporting is a really good way to take the tools that you already have in place and ask your developers to raise notes about what they think may be concerning, what have a potentiality for a major incident in the future. Now, you do not need to go reviewing pre-incident reports, but having that log right next to your post-incident reporting is a very nice way to hold that intellectual property for major reporting of incident events. If we move to that model, I think that saves us a good amount of time. It absolutely helps us with the question of who is the right person to call on PagerDuty. It's not always just the person who has the pager in their hand. Sometimes it can be one or two developers in the company that know how to fix the problem. And if they've raised that concern before, they're the ones to reach out to.
So as you're talking about, that some of these cultural changes become norm, what do you think about having, security not as an afterthought that installing an airbag after you buy a car. Do you also see any trends, positive trends in that direction where companies are, because reports come out, we do see, hey, security is no longer an afterthought, and nobody knows better than the Sonatype there. But the reality is a bit different. So, what do you see that, yes, you want that ideal situation, but what do you see in reality? And do you see any positive trend there?
Yeah. So, I mean, there are two parts of this. It's the security at the open source level and security at the enterprise level. So in the open source space, it's important to understand that this is sort of a culture where it really developed out of well-meaning volunteers. And these projects are usually maintained by anywhere from 1 to 3 people. You may recall the Log4j event in December. We all remember that. I was off of work that week and I was put right back on because that was a major cybersecurity event, right? So in that case, right, we have to remember that that is a team of 3 maintainers max, and they worked over holidays to make sure that that patch was there. So when we're considering this, maintainers of open source need to have better awareness and education of how to address cybersecurity concerns. I'm actually working with Linux Foundation right now. I got off a call right before this to ensure that we start to put training and verification that ensures that maintainers do understand cybersecurity and they're removing the vulnerabilities before they get passed down to enterprise. Secondarily, yeah, you have to start thinking of cybersecurity as your first thought, right? It has to be your first thought before you intake packages. You should look at the health of an open source package. Make sure that you have a working relationship with those maintainers if you can. And then secondly, internally, I think just the way that SRE has increasingly become a part of the DevOps team, cybersecurity is going to become increasingly part of the DevOps team. They need to be there in the active decision making around the architectural design of your process. The only reason cybersecurity used to come last was because we had a bit of a technical hangup that forced us to do waterfall, right? Cybersecurity and quality testing would typically come post-production. But that was only because the kind of cybersecurity attacks we were typically seeing were trying to attack enterprises specifically and vectoring to them with insider attacks, etc. Nowadays, they're going to go directly for the open source software that's going to provide them a backdoor into your enterprise software. So you have to know that upfront when you make the choice to put that line of code into yours.
What kind of approach companies should have when it comes to using or consuming open source code base, so that they can avoid the mistake assuming that since it's open source there are already enough eyeballs on that? That is not the case in most cases, and even if there are eyeballs, they're not looking in the right direction. So security once again should move into the pipeline of a developer, but once again it should not be relying on products. It should be part of their process. So if you can talk about that, that would be great.
Yeah. So part of this comes down to moving from a more security researcher approach to this to actually ensuring that you have automation in place. That's sort of the stage that we're at in cybersecurity, is that we have a lot of basically SCA or like scanning mechanisms in place. But unfortunately, there is a large amount of fatigue from every type of developer around a lot of these tools because they provide you with false positives, or even if they are true positives, some that you cannot remove because they are integral to the function of your code, right? So we do need to get much better at having tools that have technical empathy for your specific architectural design. I also think that in this case, as these tools improve, and they are actively improving, a big cultural shift has become an awareness that the cybersecurity has to happen outside of enterprise if enterprises are going to be helped, right? So there is a big shift at the foundation level, right? Linux Foundation, CNCF, these are just a few that I am working with to fix these massive cybersecurity issues. They need to be educated. So we do need to be getting educational resources out there, because you have a bit of a problem where A maintainer typically maintains a project because they are highly knowledgeable about the way that that code base works. A cybersecurity researcher has a completely different mechanism of training, and it would take two bodies, one mind, right? You cannot possibly get that into one person. But we can start to make sure that there are basic standards of security practice in open source that are mandatory. That is a great next step to make sure that you can validate and know that the package that you're pulling in is going to be relatively likely to be free of vulnerabilities because they are ensuring best practices and they're verified for it.
Excellent. You twice mentioned your work with the Linux Foundation. Of course, they also have OpenSSF, which is focusing purely on security. Every Linux Foundation, they have it's a foundation of foundations. Every foundation has its own focus on security. Can you talk about what work you are doing with them, and also what are the areas that you folks are actually looking at, because they recently came up with the research also. They also, as I said, they have a long history of working on some security projects. Linux Foundation was the one. They also funded a lot of open source maintainers. There's only one maintainer to maintain some SSH projects there. So they are doing a lot of work there. But I would love to understand, the work that you folks are doing with them.
Yeah. So I'll speak to one that I think is really interesting because it sticks us on this sort of security and it sort of brings us full circle on what this looks like to do it right, in my opinion. So right now I work with Cloud Native Computing Foundation. Before every KubeCon, we put together something called a bug bash. So we find their highest priority projects inside of the CNCF incubator. We scan them for vulnerabilities, and then we get their maintainer community, their contributing community, to be able to come in and fix those bugs. Now, that does mean sometimes they need a bit of ad hoc education around those, but that's a very efficient way to make sure that you are getting the training for the type of vulnerabilities that are most likely to occur in your type of architecture, right? That's very important to not just do blanket education here, but to make sure that it's targeted to what type of development this is really looking at. So in this case, we'll bring them in, we'll scan them, and then we spend about 2 weeks helping that contributor community to remove as many bugs as possible. I think our last bug bash was one of the best ones that we had. We removed, I think, a little over 1,300 vulnerabilities from 5 major open source packages. But we're going to change the strategy a little bit moving forward because having done this, having worked with these maintainers, I say that they do not have a lot of cybersecurity experience by training, but they also often have not even fully implemented a way to engage in a security protocol. For example, they will not have on their basic README documentation who is the contact and how do you want to be contacted for vulnerabilities, right? Typically, you will want to have a vulnerability disclosed by email and not within a PR if it's a serious vulnerability, so that the maintainer can patch it before it becomes further exposed, for example. These basic practices we're trying to put into place. So for this next KubeCon, as we're going into it, this bug bash is actually leaning on their metrics for CLO Monitor. This has been developed, I believe, by CNCF, but it's widely within Linux Foundation, which goes and it looks at the overall health of your project, right? Have you put best practices in place? Do you have security measures? Do you have a license in place? You'd be surprised how many of these open source packages do not state their license explicitly on GitHub. These kind of basic best practices make it so that we can upskill an entire current living generation of developers to be able to handle real-time security events. Now, I do want to speak to this idea around sort of Log4j and why was it there for 7 years. I'm sure that there are many cases of these things being here for several years. There's a couple of reasons for it. Sometimes they're not viewed as major vulnerabilities. Secondarily, Log4j is only a critical vulnerability if you're also connected to JNDI, right? It was an architectural vulnerability. We cannot say that it was just a vulnerability of a line of code per se. So you really have to think about whether or not it's a vulnerability for your code itself. But third, And this is something that I come from a machine learning background. I take the automation route to all problems, and now I'm just applying it to cybersecurity. But when I entered this space, what I found really interesting was the incredible human element to it, right? So we have to consider that the hacker on the other side of the screen is usually not sitting in a dark room alone with a hoodie. We have to understand that oftentimes these are teams of developers, sometimes paid, who also have sprints, who also have deadlines, and they are much more highly incentivized to break your code than you are to fix it, right? Sometimes as well, and this is something that really does scare me because there's no way to automate out this problem. Occasionally, you've got white, gray, and black hatters, right? So a white hat hacks for good, gray hat hacks on both sides a little bit, and black hatters are what we traditionally think about as sort of the nefarious hacker. Um, Sometimes you will have someone surface a vulnerability and they will be contacted by agents who do not want them to disclose it. These can be nation states, for example. If there is a very good, widely surfaced backdoor, it's very likely that things like Log4j were brought up dozens of times in the last 7 years, but were not processed because of concerns like that. Now, I cannot, for this specific case, validate that that occurred for Log4j, but it absolutely happens that there's an entire industry around ensuring that vulnerabilities in open source stay in place while they're being tactically utilized. We can, on the other side of that, kind of revert back to more eyes on the problem, right? If we ensure that automated checking of vulnerabilities is in place at the beginning of the open source pipeline in those packages, that makes it significantly less likely that a single individual is going to be targeted and coerced, because you then have an entire community looking at these vulnerabilities and trying to fix them in real time.
And once again, bugs will be part of software development. They are not going to go away no matter what you do, just automate it. And second is that this political factor will also be there. So I think the best approach that you said was the more we automate things, the better it is. Once again, I'll go back to the point of, yes, we should, but how much are you seeing in real where automation is happening? And if you can also talk about what work you folks at Sonatype are doing to kind of help with this as well.
Yeah, so I think right now there's a reasonable amount of automation in several products in this space if you want to do uh, just blanket code scanning, right? It's a different discussion if we're looking at runtime, and there's great solutions for that as well. But just looking at a rote overview of, do you have potential vulnerabilities before execution is absolutely important. So our best way to be able to improve these is to improve the intelligence behind this. Now, that is specifically why I joined Sonatype. They, for over 10 years, they were the original developers and maintainers of Maven Central, which holds all of the open source packages for JVM languages, primarily mostly every open source Java package, which is a huge amount of the internet. But because they've had that, they've been able to look at and recognize the ways that developers behave around open source packages, and to be able to pull in extra intelligence about what likely vulnerabilities are in place for certain types of code. I find that really interesting. They also have over 100 research developers and cybersecurity researchers who really are focusing on this problem. What's the best way to solve this problem? Really, no longer at the language level, but potentially at the JVM level, right? Find a way to capture vulnerabilities that lets you have any language sitting inside your system represented within that. That, for me, is a really exciting place to be able to go. But secondarily, I think what I find interesting about Sonatype is their willingness to put out free and open source solutions to real problems, right? It's run by a CTO who genuinely is a developer and cares about putting out solutions that work. So two things that we have developed through the time that I have been there have been a product called Lift. This is what I've been describing. When you have any open source package, you can take it, put the URL into Lift, and get a readout of all of the potential vulnerabilities, but also anything else that really would come up. What we've done essentially is put together all of the best linters for the primary languages that we're focusing on. We make sure that you have a one-time backlog of vulnerabilities because, right, in security, you should not have a backlog of vulnerabilities. You take care of that. But what's really interesting about that approach, and again, this will always be free and available for usage forever. This is meant to help solve the open source security problem. What gets really cool about that is after you have that initial vulnerability backlist that your contributors remove, every single pull request from there is then scanned for vulnerabilities, which really makes it a powerful and efficient way to make sure that you prevent them from ever entering into the open source package, let alone into enterprise.
So thank you so much for taking time out today and talk about this topic. Of course, we talked about SRE, the evolution of DevOps, their roles, but then we also talked about security, open source, supply chain security, which is really important topic. So thanks for sharing those insights. And as I said, this is a topic which is very, very relevant and important. So I look forward to our next discussion, and we can also see each other at KubeCon as well. So, but I really appreciate your time today. Thank you.
Excellent. Thank you so much.